Here we go with 4-2 notes, again in front of a live studio audience with first hour geometry class. The main thing from this section we're going to be looking at is this triangle angle sum theorem. You guys have learned this in previous classes. Now we're giving a name to it, and we need to remember what we know about the angles in a triangle. So in words here it says the sum of the measures of the angles of a triangle is 180 degrees. If I wanted to write that out for this picture, I would say that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And this is not to be confused with the sides of a triangle. Sometimes students get it in their head that all of the sides have to add up to be 180. The size of the triangle would have nothing to do with the measures of the angles. This could be a teeny tiny little triangle and the angles are all going to be 180 degrees, or it could be an extra large triangle. It wouldn't matter. So we're not going to be doing problems like this where we just have one triangle in the picture. We'll be doing pictures like this where we have maybe more than one triangle in the picture. And we need to remember things like vertical angles still apply. So vertical angles are congruent. We need to remember that linear pairs are supplementary, meaning they add up, the two angles add up to equal 180 degrees when they're in that straight line. Because that stuff will come into play too, as well as now this triangle angle sum theorem, where all three angles in a triangle add up to be 180 degrees. So I'll kind of walk you through some of these problems, the way that they're going to look. It may be helpful to pause this and try it on your own, or at least figure out what angles you know already to kind of help yourself out. So there's different angles I could answer for first here. It's not like there's just one correct way that you have to go through all of these. It just kind of depends on what you notice. For some reason, I always seem to notice vertical angles first. So looking at this, angle 2 and angle with the 78 degrees, those are vertical angles. So I would know that this angle 2 is 78 degrees. And you could make like a little list of that. And I would even recommend like putting it on your picture if you can fit it in there, because that might help you come up with a different angle. Then once I look at this triangle here, this triangle CED, do you see now I have two of those three angles? Well, I can add those together. So I have this one that's 61 plus 78. So that's going to be 139. And I can just subtract that from 180 to get angle 1. So for this one here, angle 1 is 41 degrees. So the measure of angle 1 equals 41 degrees. And then for this other triangle that I have, all three of these angles are going to add up to be 180. So again, if I add up the two that I have, I would have 98. And I can take that away from 180 degrees. So this other angle is going to be 82 degrees. Oops, measure of angle 3 is 82 degrees. For these examples, again, there's multiple different ways that you could look at them. What I start to do is I just start to fill in anything that I know right off the bat, and you might be able to go in order 1, 2, 3, but other times it might be more helpful to just fill in whatever you know. Looking at this, what I would do is I notice that angle 2 is part of this triangle. So I would add up the 57 and the 71 and subtract that from 180 degrees. That's going to make angle 2 52 degrees. And again, it'd be more helpful if you had your calculator and you were kind of doing this just to make sure Or even if you wanted to pause the video at this point and see if you can come up with the angles and then go back and just do a double check to make sure, because I will be going through these a little quickly. This next one here for angle 1, these two angles form a linear pair. So that's the way I see it. What I would do is just do 180 minus 57. So angle 1 is 123 degrees. And then lastly for angle 3, a couple of different ways that you could think about it, because there's actually 3 different triangles that are here in this picture. You could look at this triangle up here, the JKL, and all 3 of these angles are going to add up to be 180 degrees. So you could add those 2 and subtract from 180 to get 29 degrees. Another way that you could do the same one is you could look at, let me get a different color here. You could look at this entire big triangle. And then if you look at the 3 angles in those, we have this one, we have angle 2, which was 52, and then I have this entire angle, which if I added those 2 up, that would be 99 degrees. And that would just be another way. It's not that one way is better or worse than the other, it's just kind of whatever you notice might be able to kind of help you out. For this next one here, I have a lot of different angles, so I'll go ahead and write all of those down here quick, so we make sure that we get all of them. Again, your picture might be kind of small to squeeze all these numbers in for, but it might be helpful if you could kind of put the information on your picture too. And what I would do if I were you is I would just pick an angle that you know and go ahead and go from there. The one that stands out to me first is angle 7, because that's part of this triangle XYZ. So I could add these 2 up and subtract from 180. So 58 plus 65, let's see, that's going to be 123. And when I take that away from 180, I get 57 degrees. So angle 7 is 57 degrees. And then with that, I can actually figure out 5 and 6, because I have vertical angles here with 5 and 7. So 5 is 57 degrees. And I have a linear pair here with 6. So I could do 180 minus 57. So angle 6 is going to be 123 also. Once I know that angle 5 is 57, I have 2 out of the 3 angles in this triangle. I can add the 57 plus the 67, so that's 124, and then take that away from 180. Angle 4 is going to be 56 degrees. And then these last 2, these are the hardest 2, at least the first couple times that you see these. I know that angle 6 is 123 degrees. And then these marks here say that those angles are congruent. So looking at, I'll draw that triangle a little bigger. Looking at this triangle here, these are congruent. This is 123. If I take 180 minus 123, so that gets me 57. What I can do from that is I can divide that by 2, because these 2 are going to be the same angle measure. So that would make each of those for 8 and 9, 28.5 degrees. So before I move on to this next part, I want to just point something out quick. You may notice that some of these angles are very similar. Like the 123 that I had here, I got that when I added these 2 up. 58 plus 65, I got 123. And this part here being 123, that's not a coincidence. That is something very special that we're going to talk about in just a second. If all 3 of these are going to add up to be 180, and these two add up to be 180 because they're a linear pair, this will always be the case. And this is actually our next theorem. Let me just scroll down quick. It's called the exterior angle theorem. And before we get into what that theorem actually says, we need to know what an exterior angle is. If you draw a triangle, you have the three angles that are on the interior, which would be these three here. If you extend one of those lines out, and you could extend any one of these sides out, what we have is we have an exterior angle. So in this picture here, angle 4 is an exterior angle. The exterior angle the exterior angle theorem says that if you take the measure of the exterior angle it equals the sum, meaning you're adding them together, the sum of the two remote interior angles. Okay, Jake. So looking at this picture here, the remote interior angles are the ones that are not adjacent to the exterior angle. So the remote ones would be angles 1 and angle 3. So the exterior angle theorem says in this case that the measure of angle 4, the measure of the exterior angle, is equal to the sum, meaning I'm adding together, the two remote interior angles. So that would be angle 1 plus the measure of angle 3. And you won't always need to know this theorem. Like for that last example, we didn't know it, but we could still answer the different questions. But sometimes when you have variables, it will be important that you have this theorem down so that we can get this figured out. So in this picture here, this is my exterior angle. So the exterior angle being 2x minus 15 is going to equal those two remote interior angles, being these two added together. So in this case, it's x plus 50. And those could be anything with different variables. You're just going to plug in whatever it says. So I'm going to solve this for x, and then I need to make sure I go back and answer the question that's being asked. So when I solve this for x, I get x to be 65. And then looking at this problem though, it doesn't say solve for x, it says find the measure of angle JKL. So JKL is this angle here, this exterior angle. So 2 times 65 is 130 minus 15. This exterior angle would be 115 degrees. Looking at this whole picture, I would probably plug it in for both of these things just to make sure it makes sense. This angle is going to be 65 degrees. And then if I look at either linear pairs or all three angles within this triangle, this angle is going to be 65 degrees as well. So I can double check this a couple different ways. These two add up to be 180, and then all of those three add up to be 180. So hopefully this kind of makes sense why this is the case. Again, it will be important on the test. There will be some questions that you have to know this to solve, like for variables with. But most of the time you won't need this because you could always come up with this one first and then just know that that one's its linear pair when we just have numbers in all of the angles. Okay, and this last part will go a little quicker. So this last little bit, there's an introduction of a couple of different corollaries. A corollary is like a theorem. It's actually a type of theorem that follows directly from another theorem. So it's not essential that you remember these corollaries, but these might just make your life a little bit easier if you do. The first one says if you have two acute angles of a right triangle, so these two here, the thing that you would know about them is they have to add up to be 90 degrees also. They have to be complementary. Because if all three of these angles are going to add up to be 180, and this one's already taking up 90 degrees, that means that the other two have 90 degrees left over when you add them together. And then for this next one, it says there can be at most one right or one obtuse angle in any triangle. Because again, all of the angles have to add up to be 180. It wouldn't make sense that you could have two 90-degree angles, because that wouldn't leave you with anything left over for the third angle. Or you couldn't have two obtuse angles for the same reason. So then down here answering these questions, you could use these corollaries. Again, you don't need to know the names of them or anything, and you don't even really have to know them because you know that all three angles add up to 180, but I'll kind of show you how you could use them here. So I'll just go ahead and write all those out quick. The measure of angle 1, measure of angle 2, measure of angle 3, and the measure of angle 4. Oops. So looking at this triangle, this right triangle, I know that these two acute angles are going to add up to be equal to 90. So I can just do 90 minus 52. So angle 1 is 38 degrees. Angle 2 is part of this bigger right triangle here. And again, these two angles are going to add up to be 90. So I could do 90 minus 38. And I was giving you the answer. The answer is 52 degrees. And then once I know this is 52, that allows me to give the answer for angle 3 because these are up here and they both add up to 90. So angle 3 is going to be 38 degrees. And then for the last one, for this right triangle here, we know that this is 90 because that one next to it's 90, and that's that straight line. So those two are going to add up to be 90 also. So that would make this one 52. I hope this helps a lot, and we'll make sure that you get a lot of practice on this in class. Have an awesome day.
Yeah.